Welcome to MathGPT. In this video, we'll explore an important concept in astronomy, the frost line. The frost line played a crucial role in shaping our solar system as we know it today. So, what exactly is the frost line? The frost line, also known as the snow line, is the distance from the sun in the early solar nebula where it was cold enough for volatile compounds to condense into solid ice grains. These volatile compounds include water, ammonia, and methane, substances that can easily change from gas to liquid or solid when temperatures drop. Let's visualize how this works. About 4.6 billion years ago, our solar system began as a rotating cloud of gas and dust called the solar nebula. The center of this nebula became hotter as material collapsed inward due to gravity, eventually forming our sun. This created a temperature gradient, very hot near the center, and progressively cooler farther away. Now, let's explore the significance of the frost line. In our solar system, the frost line was located approximately 2.7 astronomical units from the Sun, roughly between the orbits of Mars and Jupiter. This created two distinct regions with very different characteristics. Inside the frost line, it was too warm for ices to form. Only metals and rocky materials could condense into solids. Outside the frost line, it was cold enough for volatile compounds to freeze into ices, in addition to the metals and rocks that were already solid. This temperature boundary has profound implications for planet formation. Inside the frost line, where only rocks and metals could condense, there was less solid material available. This led to the formation of smaller, rocky planets, which we call terrestrial planets: Mercury, Venus, Earth, and Mars. Outside the frost line, the availability of ice particles provided much more solid material. This allowed the formation of larger cores that could then attract thick atmospheres of hydrogen and helium gas. The result was the formation of the gas and ice giants, Jupiter, Saturn, Uranus, and Neptune. Let's now look at the current structure of our solar system and how it reflects the frost line's influence. The frost line explains why we see a clear division in our solar system: small, rocky planets closer to the sun and large gas and ice giants farther away. The dividing boundary sits at approximately 2.7 astronomical units from the sun. It's important to note that while the orbits we see today are stable, some of the planets may have migrated from their original formation positions. Let's summarize what we've learned in a table. To conclude, the frost line is a crucial concept that helps us understand the structure and formation of our solar system. It explains why we have rocky terrestrial planets close to the sun and gaseous giants farther away. The frost line acts as a temperature boundary that determined what materials could condense and form solid bodies in different regions of the early solar nebula. Thank you for watching. I hope you now understand how this simple concept of the frost line helped shape our entire solar system.